Hi guys, today we are going to focus on one thing and one thing only, which is division and polynomials. So first we're going to open it up by taking a polynomial and dividing it by a monomial. That is just code for a polynomial that has one term. And then we're going to spice it up by continuing the division unit, but in this case we're going to be dividing by polynomials that have more than one term. So let's go ahead and do this. So we have fun problem number 1, the directions straight to the point. Those are my kind of directions. Alright, so we have 8x squared minus 4x plus 1, and we are asked to divide this polynomial by 2x. The question is, do I really have to use long division? I mean, you can always use long division if you want, but check it out. You only have to use long division if you're dividing by more than one term. In this case, since we're only dividing by one term, then we don't have to use long division. Now, how do we divide by a monomial? Pretty much, I'm going to use my fancy math works. We're going to take each term in the dividend and divide it by the divisor. So in English, split it up, okay? So we're going to take this first term, 8x squared. What's going on with it? We're going to divide it. We'll use the fraction bar. Divided by what? 2x, okay? Then we have minus 4x. So let's go ahead and split it up. Minus 4x. What's going on with it? We're going to divide it by 2x. Then we're adding 1, so plus 1. And then what's going on with the 1? We're dividing by 2x. So in short, if you're only dividing by a monomial, let's go ahead and split it up. And then we're going to use the exponent rules to simplify each fraction. So let's do this. 2 and 8, quotient of 8 and 2 gives us 4. But let me go ahead and use my cross-counting notation. Okay. Quotient of the x's, x squared over x will give us x. If you need a reminder, let's go ahead and look at our earlier video. But it's like silly exponent rules. They make me so mad. Okay, so if we have a division problem, we're going to keep the base and subtract the exponents. Love yourself and subtract the smaller exponent. So let me highlight the exponent on this x by itself. So we're going to divide top and bottom by x. So x goes into itself once, and into x squared, we're going to subtract the exponents. 2 minus 1 will give us 1, so that will leave us with 1 factor of x. So the first mini problem simplifies to 4 times x over 1, which is just 4x. That's it, we're done. Mini problem number 2, quotient of 4 and 2 is 2. Let me use my cross-casting notation for fake extra credit. And the quotient of the x's gives us 1. Oh, they cancel out. Why? For the same reason that anything divided by itself is 1. So that will leave us just with minus 2. And then third mini problem, there's nothing to cancel, so that's it. Okay. Oh, is it a problem that we have a fraction? No, fractions are fine. So that is it. Okay, so we're going to do another spicy problem. Okay, problem B. So we have open parenthesis 12 times a, that is raised to the 8th power, b squared plus 10 a squared b to the 5th c to the 6th minus 18 a b c to the 9th, where am I, close parenthesis, divided by 6a squared bc. Okay, so technically I'm supposed to wrap up the 6a squared bc kind of like I was supposed to subtract, kind of like I was supposed to wrap up the 2x, but it's okay, you understand me. Actually no, I need to have good notation. Alright, cool. So with that being said, okay, so we have this 3-term polynomial, and we're asked to divide it by 6a squared bc. The question is, do we have to use long division? And the answer is no. Why not? Because we don't have to use long division because we're not dividing by more than one term, or like in short, we're only dividing by one term. So let's go ahead and split it up. We're going to take each term in the dividend and divide it by a divisor. So mini problem number 1, first term, which is 12a to the 8th power times a to the 8th power b squared over our divisor of 6a squared bc. Then we have plus something, so we're going to add to it the second term. What's going on with the second term? That is also being divided by 6a squared bc. Sorry, I switch out my a's. Okay, then we're subtracting the third term. 18a b c to the ninth, and what's going on with it? We're dividing it by 6a squared bc. Okay, the toughest part about polynomials and dividing by a monomial or one term is just to remember how to start it. So we're going to split the problem. In this case, since we're dividing into, once again, a 3-term polynomial, then when we split it, we will pretty much have 3 mini problems. Let's use exponent rules to simplify. If we get something clean, cool, and if we have a fraction, that's okay. We're not gonna cry about it. All right, first mini problem. 6 goes into 12 2 times. Quotient of the a's, you know, if you need to vent out your frustration, go for it, and if you don't need to, then don't. Okay, but I need to. So it's like silly exponent rules. They make me so mad. So if we have a division problem, we're gonna keep the base and subtract the exponent. So let's do this. Quotient of the a's, we're gonna divide by a squared. A squared goes into itself once, and into a to the 8th, we got 8 a's. I guess my fingers are too big. We got 8 a's. We take away 2 a's. That will leave us with 6 a's. Remember, we subtract. Okay, I'm going to go ahead and turn off this light, even if it's a more romantic setting. I think it looks better. All right, quotient of the b's. We have 2 on top, 1 on bottom. So guess what? We're going to cancel out one factor of b. b goes into itself once, and into b squared. We got 2 b's, we take away 1 b. I gotta use the right finger. We have 2 b's, we take away 1 b. That will leave us with one factor of b. Quotient of the c's, that's it. There's no other c. So let me go ahead and write down what we have. In the numerator, we have a 2 times a to the 6 times a b. In the denominator, we have 1, 1, 1 times c, so that's all over c. Okay, one mini problem down, 2 more to go. Mini problem number 2. 10 and 6 have a common factor of 2, so let's do this. 2 goes into 6 3 times, and into 10 5 times. Take your time with the quotient of the variable factors. Quotient of the a's, a squared divided by itself will give us 1. Quotient of the b's, 5 on top, 1 on bottom. We're going to divide by one factor of b. Remember, keep the base and subtract the exponents. B goes into itself once, and into b to the 5th. 5 minus exponent of 1 will leave us with 4. So that will leave us with 4 factors of b on top. Please review the exponent unit if need be. Okay. Quotient of the c's, we got 6 on top, 1 on bottom. So we're going to cancel out one factor of c. c goes into itself once, and into c to the 6th. Remember, keep the base, subtract the exponents. 6 minus 1 will give us 5, so that will leave us with 5 factors of c. So let's go ahead and write down what we have. We have plus the numerator, 5 times the b's times the c. So it'll be 5 b to the 4th, c to the 5th, fraction bar, over 3 times all these ones, which is just 3. So 2 mini problems down, 1 more to go. 6 and 18 have a common factor of 6, so 6 goes into 18 3 times. Quotient of the a's, we got 1 on top, 2 on bottom. Let's go ahead, cancel out one factor of a. A goes into itself once, and into the bottom. Remember, when we're dividing two things that have the same base, let's keep the base and subtract the exponents. 2 minus exponent of 1 will leave us with 1, so that will leave us with one factor of a. Quotient of the b's, b divided by itself will give us 1, so they cancel out. Quotient of the c's, we have 9 on top, 1 on bottom, so let's go ahead, cancel out one factor of c. C goes into itself once, and to c to the 9th, again, keep the base, subtract the exponents. 9 minus exponent of 1 will leave us 8. Will leave us with 8, so that will give us 8 factors of c's. So let's go ahead, bring it down. So we have minus 3 times 1 times 1 times the c, so that will give us 3c to the 8th over a times these ones is just a. Okay, so after we split the problem, we had 3 mini problems. We simplified all 3 and we're good. So let's go ahead and put out this fun problem that I don't think you're quite expecting in this unit. So we have 562 divided by 5. I know, curveball. Okay, and then I'm gonna put a little love note. I want you to give old school answers. Okay, give old school answers. What do I mean by old school answers? So pretty much like when you were like in TK or preschool, wherever you did long division, we wrote answers like 2 remainder 1, 2 remainder 2. So what I want to get at is Don't get all creative with the decimal point. Okay, so if you got a remainder, go ahead, spit it out. Okay, so let's do this. So we have 5. How many times does it go into 562? I promise there's a reason to, there's a purpose to my madness. So steps for long division, we're going to divide. 5 goes into itself once. So let me go ahead and remind myself, because it's been a long time that I've actually done long division. Okay, I'm so used to the calculator. So steps for long division. So we're going to divide, then we're going to multiply, and then we're going to subtract. So 5 minus itself gives a 0. And then if there's another digit, we're going to bring down. Cool. Let's go ahead and bring down the 6. And then what are we going to do? We're going to divide again, but we're not going to put divide again. So we'll just say repeat, because if we put divide again, then it's going to be the never-ending journey. So then 5, so divide again. So 5 goes into 6 once. Then we're going to multiply. 1 times 5 is 5. Then we're going to subtract. 6 minus 5 is 1. Oh, we will subtract, no. Then we're going to bring down. Cool. And then what are we going to do? We're going to go ahead, repeat. Okay. So 5 goes into 12. ¿Cuántas veces? Sorry, 2 times. So 2 times. And then we're going to, I lost track where I put on my check mark. Sorry. Okay. So we divide, multiply, subtract. Okay. So we just divided. Let's go ahead, multiply. 2 times 5 is 10. And then we're going to subtract. And again, we want old school answers. Don't get all excited and put 0.0. Okay. So the answer in the form that it was requested was 112, and then we want old school answers, remainder 2. Okay, something that I want to point out, later on in life when you were in kindergarten, it's like, oh, let's write the remainder as a fraction. Okay, so if we wrote the remainder as a fraction, so the quotient is 112 plus a little extra. Okay, we got 2 extra things, and we divided by 5. So as a fraction, you know, we wrote the answer as 112 plus 2/5. But because we have a whole number in a proper fraction, we can actually add the 2. You know, the sum will give us 112. The sum will give us 112 and 2/5. Okay. But again, there's a reason to my madness. So let me go ahead and look for my sheet of paper. Okay, if you can do this problem, you're going to be able to knock out these crazy looking problems that we're going to knock out in a bit. So we're going to do 3 problems where unfortunately we're going to have to use long division. So stay with me, okay? So I'm going to keep this problem, okay? So how do we use long division to divide polynomials? I kid you not. If you can do like this old school problem, you can do any long division problem involving polynomials. It's just gonna look spicier, but I know you can handle it, okay? So trust yourself, okay? To divide polynomials using long division, you're gonna use the same strategy as if working with whole numbers. Divide, multiply, subtract, bring down, and then repeat or spit out the remainder. Okay, but before we start to actually divide, let's go ahead and look at the prerequisite steps. When it comes to polynomial long division, there's 2 things that need to have been met. 1 is a divisor in descending order. 2 is a dividend also in descending order, and 3 is there a term for each power going down in the dividend. Okay, so let me explain. So the issue with this problem is that it's not ready for long division. Why not? We're gonna look at the divisor and ask ourselves, is it in descending order? And the answer is no. Why not? Because the degree is 2. So I'm expected to see x to the second, x to the first, constant. Okay, we have some but in auto order, so let's fix this. So we have x to the second, we don't have an x to the first, it's okay, constant. Okay, x to the second, x to the first missing, constant. Good. For the dividend, what we're dividing into, it doesn't suffice just for the polynomial to be in descending order. We need to have a term for each power going down, and if not, then we'll do some 0 placeholders. So the degree is 5, so I'm expected to see x to the 5th, 5. Oh, that's too zoomed in. Okay, so the degree is 5, so I'm expected to see x to the 5th. 4, 3, 2, 1, blast off. Okay, so we have our x to the 5th, but we don't have an x to the 4th. Okay, so we're gonna do what we call a 0 placeholder. The reason why we call it a 0 placeholder is because we want to use the number 0 to reserve the place of the missing power of the variable. So we have an x to the 5th. I'm expected to see an x to the 4th. Did I say that right? I'm expected to see an x to the 4th. We don't have it. We can't force it. So 0 placeholder. So we're going to put plus 0. Why are we allowed to do this? We could do this because adding 0 to an expression is not going to change it. You know what? Remind me not to use a highlighter anymore. Okay? But since we want to highlight that this is where the degree 4 term should be, we're going to write 0 as 0 times x to the 4th. Okay? So we just have a very creative way to write 0. So we have x to the 5th, 0 placeholder for x to the 4th. Do we have an x to the 3rd? Yes. Keep going down. We should have an x to the 2nd. We don't, so another 0 placeholder. And the question is, why do we have to put a 0? Well, check it out. If we don't put a 0 and we just put plus x squared, adding x squared to this expression is going to change the meaning. But if we write x squared as x squared times 0, well, pretty much we're just adding a weird way to add 0. And again, adding 0 is not going to change my expression. Okay, I lost my countdown. So if we have x to the 5th, 4, so 5, 4, 3, 2. We need an x to the 1. And we do. Okay, so minus x. So let's do the countdown. 5, 4, 3, 2, 1. I need my blast off or my degree 0 term. The degree 0 term is the constant term. We don't have a constant term, so let's go ahead and write it out. And then we will proceed with the long division. So this problem, I don't really like it, okay? But the reason why I did is because I wanted to highlight how do we prepare for long division. To prepare for long division, 1, look at the divider, make sure it's in descending order. 2, look at the dividend, make sure it's in descending order. And then 3, make sure there's a term for each power going down in the dividend. Now someone said, hey, how come we didn't put a 0 placeholder for the divisor? I mean, you could if you want, but it's not necessary. And if it's not necessary, if I can avoid more work, then I would choose to avoid it, because then I get a little nervous. Okay, so let's go ahead, do 3 problems, and then that'll be the end of this video. Okay, so we are asked to divide, okay, and then we want to write our answer in the form quotient plus remainder over divisor. So let me explain that. So going back to our old school problem, so we were asked to divide, and then we write the answer in the form, quotient plus remainder over divisor. Okay, before I forget, I'm sorry, how can we check our answer? So from back in the day, we're like, okay, so to check, I don't think we really wrote the following, but I'm gonna go ahead and write it out. We're gonna take the quotient, multiply it by the divisor, add to it the remainder, and then hopefully that gave us the dividend. Okay, so we're going to take the quotient, which was what, 112, multiply it by the divisor, which is 5, add to it the remainder, which is 2, and that needs to give us the dividend. Okay, actually I'll write it out, which is 562. Okay, so let's see. Okay, quotient times divisor plus remainder needs to give us back the dividend. Product of 112 and 5 will give us 560. Sum of 560 and 2 will give us 562, just like our dividend. Okay, I don't know if you can see that, sorry. Okay, so again, the steps that we use to use long division with whole numbers and to check is the same exact steps that we're going to use for long division and polynomials. Okay, sorry, I forgot the checking part. Okay, so we have 3 problems. None of them are typed, so I guess they're all a mystery. Okay, so we have open parenthesis, x squared plus 5x minus 7, close parenthesis, and we want to divide that by x plus 3. Fantastic. So the question is, do I have to use long division? The problems don't state. The problems just state to divide. So again, if we're dividing by more than one term, then yeah, we have to use long division. If we are only dividing by one term though, then no, we don't have to use long division. But in this case, we do. So let's prep it up. So one, we're going to take the divisor and make sure it's in descending order. So the degree is 1. So we should have x to the first constant. Okay, and we do. So no, sorry, I lost my train of thought. So it's in descending order. So let's go ahead, prep it up. For the dividend, or what we're dividing into, there's two things that need to have been met. One, is it in descending order? And two, do we have a term for each power going down? So the degree is 2. So we're expected to have x to the second, x to the first constant. Okay, so that's like our degree 0. So we have x to the second, x to the first constant. Okay, cool. Fantastic. So it was already perfect as is. That's because it's problem A. Okay, so now let's go ahead and divide. So again, the steps that we use to divide whole numbers are the same steps that we're going to use for polynomial division. We're going to divide, multiply, subtract, bring down, and either repeat or spit out the remainder. Now, this is a fun thing. Yes, we are dividing by x plus 3, but when it comes to the division part, we only focus on the first term. Okay, so I want to know how many times does this first term go into the very first term that I see. I know you're a genius, okay? I know you can like do that in your head, but I sincerely can't. Okay, so I'm gonna bust out a thinking area. Okay, so I'm like, hey, how many times does x go into x squared? How many times does x go into x squared? Well, we keep our cool, and that simplifies to x. Okay, so thanks to our thinking area with confidence, I'm like, okay, x goes into x squared exactly x times. Line it up. Do you have to? No, but it will minimize the confusion. So we just divide it. What do we do thereafter? Multiply. At this point, nothing gets ignored. So let's go ahead and do this. So we have x times x will give us x squared. Please line it up. X times 3 will give us 3x. Fantastic. So we divided, we just multiplied, then we have to subtract. Okay, when we subtract, we just put the minus sign in front. When we had whole numbers, well, because they were just numbers, okay, we put minus minus. Okay, but right here we have a polynomial. Okay, so we can't just put a minus, because then we're only gonna be subtracting the x squared. We're gonna have to wrap it up. Okay, so let's go ahead, subtract. Now at this point, it's really up to you how you want to show the subtraction. It just depends how you process things. Okay, oh, sorry, I was trying to play with the light. I think that's a little bit better. Okay, so you can go straight to answer, or you can show some work. I'm gonna do it both ways. I'm gonna go to answer, and then I'm gonna show work. Okay, so when we subtract, x squared minus x squared gives us 0. Well, they cancel. I'll pretend I scratched it out. 5x minus 3x, I think it's 2x. I think. Okay, now me writing out the answer right now, x squared minus x squared cancel. 5x minus 3x is 2x. Is me just writing 2x is probably like one of the cleanest ways to show the subtraction. But the zigzag action doesn't really work for me, because I don't subtract with confidence. So what am I gonna do? I'm gonna bust out my pre-algebra skills and add the opposite. Okay, so let's do this. When we distribute, bad math, when we distribute the negative by adding the opposite of a positive term is a negative term. Opposite of adding 3x is subtracting 3x. Now, how am I going to make this plus look like a minus? You know what? I think we are so used to like, oh, let's make it like a minus by making it really dark. Well, that's just going to be the ugliest plus sign ever. So what I'm going to do, I'm just going to circle it and then put a minus on top. Okay, my arrow is in it. Okay, so we just took care of the subtraction sign, or we added the opposite, so then we can safely change it to plus. So now with confidence, because I no longer have to do the zigzag action, I'm going to subtract with confidence. So let's do this. X squared minus x squared gives us 0, or we say it cancels. 5x minus 3x, now with confidence, gives us 2x. Okay, so we just subtracted. So steps for long division: divide, multiply, subtract. If there's another digit, for us, if there's another term, bring it down. Okay. And like with regular numbers or whole numbers, anytime you bring down something, guess what? You're going to have to repeat the fun. Okay? So again, I'm supposed to ask myself, how many times does x plus 3 go into 2x minus 7? But again, for the division part only, we only focus on the first term. How many times does the first term go into the very first term that I see? Okay, I know you could do it in your head because you're awesome, you're cool like that, but I really can't. Okay, so I want to know, how many times does the first term go into the first term that I see? So how many times does x go into 2x? We got it right here, and looks like this goes, the x's cancel, so that will leave us with 2. Okay, so now with confidence, x goes into 2x exactly 2 times. So let's go ahead, line it up, and 2 is positive. Okay, so we just divided. What do we do after we divide? Yeah, you guessed it. Not guessed it. Yeah, you said it. Multiply. So let's multiply 2 times x plus 3. Okay, 2 times x will give us 2x. 2 times 3 will give us 6. Fantastic. So steps to long division: divide, multiply, subtract. Let's go ahead, subtract using the notation of your choice. Okay, you can go straight to answer, or you can add the opposite. I already told you which one I do. Okay, so when we add the opposite of a positive term is a negative term. Opposite of a positive term is a negative term. Okay, we just took care of the subtraction sign, so now we can safely add what we say we're going to do, which is add the opposite. 2x minus 2x will give us 0, or we say it cancels. Negative 7 minus 6 will give us negative 13. Okay, so steps to long division: divide, multiply, subtract. If there's another digit, bring it down. There's no other digit, so there's nothing to repeat. So now we're going to go ahead, list the remainder. Okay, so we are asked to write our answer in the form, where am I? Quotient plus remainder over divisor. Okay, in English, tell me what the answer is, and then if you have a remainder, write it as a fraction. So let's go ahead, label some of these things. In this case, the number of times that it goes in evenly, that is our quotient. Divisor, that is just code for whatever you divide it by. Remainder, well, you know that one. Okay, whatever's left over. And then maybe I don't have it like present, but dividend, that is code for what you divided into. Alright, so we don't need the dividend to write the answer, but I wanted to point out, because for this problem we'll check our answer. Okay, so the quotient, where am I? So the quotient is x plus 12. X plus 2. Because we have a remainder, we need to write the remainder as a fraction. So plus a little something. Okay, the remainder is negative 13, and then we divide it by x plus 3. So as a fraction, the remainder is negative 13 plus x over 3. Okay, a little pet peeve of mine, sorry, okay, moment of truth, is when students don't center the fraction bar about the plus sign. Okay, sometimes they make it, I can't explain it, okay, but yeah, I would appreciate if you do. Now let's go ahead and check it. This will be the only problem that we check. Okay, so how do we check? We're going to take the quotient, multiply it by the divisor, add to it the remainder, and then make sure it gives us the dividend. Okay, so where am I? Quotient times divisor plus remainder. I need to know if it gives us the dividend. I'm going to go ahead, just write the word dividend, because if I write the actual dividend, x squared plus 5x minus 7, I feel like I'm going to have to solve something. Alright, so let's FOIL it out. Product of the first terms will give us x squared. Product of the outer terms, 3x. Product of the inner terms, where am I? 2x. product of the last terms gives us 6. And adding negative 13 is the same as subtracting 13. Let's go ahead, simplify, and then make sure we get the dividend. So we have x squared. Sum of the x's will give us 5x. Sorry for that. Difference of 6 and 13 will give us negative 7. And I'm really hoping this is what we divided into. And it is. Where am I? X squared plus 5x minus 7. So we checked it with confidence. Okay. I'm having a moment of how many problems we should do. You know what? I think we're gonna do one more, okay? Just because keeping it with the length. All right. So problem B. Where am I? Okay. Problem B. We have open parenthesis x to the 4th minus 9 minus x squared divided by 4 plus x squared. No, you know what? You twisted my arm. We'll do all three. Okay, this was supposed to be our third problem, so it's supposed to be spicier. So sorry for attacking it right now. Let's go ahead and do this one, and then we'll wrap it up with the original problem B. Okay, so the question is, do we have to use long division? Yeah. Okay. Why? Because we're divided by more than one term. So let's go ahead and do this. First thing we want to do, we want to look at the divisor, make sure it's in descending order. We don't have to worry about 0 placeholders for the divisor. So the degree is 2. It will be nice if we had an x to the 2nd, x to the 1st, constant. Okay, so we have x to the 2nd, no x to the 1st, but we have a constant. Okay, for the divisor, we just need to put it in descending order. Let's go ahead and look at the dividend. The degree is 4, so we're expected to have an x to the 4th, x to the 3rd, x to the 2nd, x to the 1st constant. Okay, so let's do this. We have an x to the 4th, so the degree is 4. We don't have an x to the 3rd, so 0 placeholder. So we'll write x to the 3rd as x to the 3rd times 0. X to the 4th, x to the 3rd, we have an x to the 2nd. X to the 4th, 4, 3, 2, x to the 1st. We don't have an x to the 1st. Let's go ahead and put another 0 placeholder. So x times 0. So we have x to the 4th, x to the 3rd, 4, 3, 2, 1, blast off, our constant term or degree 0 term. And we do have it, minus 9. So again, before you actually jump into it to the long division, you need to prep it up. So 1 is a divisor in descending order, 2 is a dividend in descending order, and 3, do we have a term for each power going down in the dividend? So let's do this. Let's go ahead and divide. Pretend I wrote the direction. So for the division, we always focus on first term into first term. So I want to know how many times does x squared go into the first term that we see. Go ahead, spit out the answer, but you know my speech. I'm always going to bust out the thinking area because I don't have that confidence as you. And x squared goes into x to the 4th, exactly x squared times, line it up. Okay, so we have x squared, steps for long division, divide, multiply, subtract. Let's go ahead and multiply. X squared times x squared will give us x to the 4th. X squared times 4 will give us 4x squared. Please line it up. Steps to long division. Divide, multiply, and then subtract. Use the let me put a plus sign. Yeah. Use the notation of your choice to show the subtraction, okay? But I do need to see some subtraction. At the very minimum, this wrapped up. And then if you want to go straight to the difference, go for it. If you want to add the opposite like we're about to, go for it, okay? So let's go ahead, take care of the subtraction sign. We'll add the opposite. Opposite of a positive term is a negative term. Opposite of adding 4x squared is subtracting 4x squared, okay? So let's go ahead, switch it to plus, okay? X to the 4th minus itself gives us 0, or we say it cancels. Okay, for dramatic effect. 0x cubed plus nothing else is still 0x cubed. And the question that I get is this: do I have to bring down the 0x cubed? I mean, you can do whatever you want, but check it out. it's just a 0, so we don't have to bring it down. Why not? For the same reason that we don't write x to the 4th minus x to the 4th is 0x to the 4th. It's just going to cause unnecessary confusion. Okay, let's do this. Negative x squared minus 4x squared, with confidence negative 5x squared. Okay, so steps to long division, how are we going to handle it? Divide, multiply, subtract. If there's another digit, or for us another term, bring it down. So let's go ahead, bring it down. Do we bring the 0? Yeah, we don't skip any terms. Okay, so steps to long division, divide, multiply, subtract. If there's another term, bring it down. And anytime you bring down something, you guessed it, the fund recycles itself. So let's divide. For the division part, remember, for polynomials, the question is how many times does the first term go into the first term that we see? If you don't need a thinking area, then don't. But again, you're not going to take the test for me, so I'm going to write the thinking area. And then with confidence, I'm like, oh yeah, x squared goes into negative 5x squared, exactly negative 5 times. So let's do this. Line it up. Okay, negative 5 is a constant. Line it up in the column for the constants. All right, so let's do this. Steps for long division. Divide, multiply, subtract. Let's go ahead and multiply. I need my fingers. Negative 5 times x squared will give us negative 5x squared. Negative 5 times 4 will give us negative 20. Line it up. Okay, so in this case, we got bumped to the next column. It's okay. Okay, steps to long division. Divide, multiply, subtract. Let's go ahead, subtract. So we usually bring down one term at a time, but in this case, since we got bumped into the next column, surprise, we're going to have to bring down the next term. Why? Because then we don't bring it down, we're not going to have anything to subtract from. So let's do this. So steps to long division. Divide, multiply, subtract however you feel like it. But I do need to see the minus and the parentheses wrapped up. So let's go ahead, add the opposite. Opposite of a negative term is a positive term. Opposite of a negative term is a positive term. Let's go ahead, add the opposite. 5x squared, negative 5x squared plus 5x squared will give us 0. 0x plus nothing is still 0, so there's no need to bring down the 0. Negative 9 plus 20, I think that's 11. Hopefully I did it right. There's no more terms to bring down, so we're good. Go ahead, write our answer in the form quotient plus remainder over divisor. We're not going to check our answer, but if this was a quiz or a test, please check it because there's no partial credit. Okay, the quotient is x squared minus 5. We're going to add to it the remainder. The remainder is 11. And we divide it by x squared plus 4. So as a fraction, the remainder is 11 over x squared plus 4. Okay, so now we're going to do our third and final problem, which was supposed to be our original problem B. Sorry. I'm always at a crossroads. Should I do more or should I do less? And this is the thing. I'm gonna vent with you guys. Whether I'm doing the lecture video, so I'm seeing you face to face. If we're seeing each other face to face, students don't say anything because they're so nice, but their faces say, oh, I want to leave. Doesn't matter how exciting I am, they want to leave. And if I do a long video, I want to leave. But then this is the thing. If I make the video short, I'm only going to do one problem. It's kind of hard. It would be nice if we had more than one problem. Okay, I digress. Venting over. Cool. All right. So for this problem, do we have to use long division? Yes. Why? Because we're dividing by more than one term. So let's prep it up. So for the divisor, 1 is it in descending order? In this case, it is. 2 is a dividend in descending order. No, it's not. 3, do we have a term for each power going down? You know what? I really can't eyeball it. So let's go ahead and do this. So the divisor, we have 5x minus 3 and I want to know how many times does it go into this bad boy. So the degree is 3, 1, 2. The degree is 3. Let me circle it. So if the degree is 3, we're expected to have x to the third, x to the second, x to the first constant, okay? And I think we have all of them. X to the third, x to the second, x to the first, constant. So that's our degree 0 term. 3, 2, 1, blast off. Okay, so let's go ahead and do this. Okay, so again, when it comes to long division in polynomials, yes, we are dividing by 5x minus 3, but for the division part only, we just focus on the first term. How many times does the first term go into the first term that we see? Again, you can spit out the answer like candy, but I can't. Like, I really can't. Okay, so with confidence, I'm going to go ahead and do a thinking area and then know that I nail it. So 10x cubed over 5x gives us 2x squared. Okay, let's go ahead and line it up. Steps for long division: divide, multiply, subtract. Let's go ahead and multiply. Move your fingers. 2x squared times 5x will give you 10x cubed. 2x squared times negative 3 will give you negative 6x squared. Steps to long division: divide, multiply, subtract. Okay, and again, you can give me the difference right now, or you can add the opposite. It's a personal choice. Let's go ahead and add the opposite. Opposite of a positive term is a negative term. Opposite of a negative term is a positive term. We added the opposite so we can safely switch it to plus. 10x cubed minus 10x cubed will give us 0. Okay, they cancel out. Negative 26x squared plus 6x squared will give us negative 20x squared. Fantastic. So steps to long division: divide, multiply, subtract. If there's another term, bring it down. So plus 17x. And you know the drill. Anytime we bring something down, we gotta repeat the division cycle. So for the division cycle, it's always how many times does the first term go into the first term that we see. And I know you're on it like, this is easy. 5x goes into this, a bunch of times. I really don't know. So I'm going to bust out a thinking area. So we have negative 20x squared over 5x. And then with confidence, that gives us negative 4x. So let's do this. 5x goes into negative 20x squared, exactly negative 4x times. Go ahead, line it up. Where am I? X term, X term. Steps to long division: divide, multiply, subtract. Let's go ahead and multiply. I need my fingers. Negative 4x times 5x will give us negative 20x squared. Negative 4x times negative 3 will give us 12x. Steps to long division: divide, multiply, subtract. And the speech, that's the same. Subtract however you like. Give me the difference or add the opposite. It's a personal choice. Go ahead, add the opposite. Opposite of a negative term is a positive term. Opposite of adding 12x is subtracting 12x. We already took care of adding the opposite, so we switch it to plus. Negative 20x squared plus 20x squared will give us 0, or we say it cancels out. 17x minus 12x is, I'm having a moment. This is why we need to sleep. Gives us 5x. So I think for the last time, steps to long division: divide, multiply, subtract. If there's another term, bring it down. Oh, we're so tired. I know, me too. I'm going to take a nap, okay? So we divided a bunch of times, but check it out. Since there are not going to be any more terms to bring it down, then you know that this will be the last division cycle. Okay, so let's do this. So first term into first term. I want to know how many times does the first term that I see go into the first term that I see. And you know the speech. You're a genius. But I will always show my thought process. I love speaking to myself. Okay, quotient of 5x in itself will give us 1. So with confidence, I'm like, oh yeah, 5x goes into itself exactly 1 time. So let's do this. Line it up on the column for the constants. 1 is positive, so we'll put plus 1. And for the final time, let's go ahead finish this division round. So steps to long division: divide, multiply, and then subtract. 1 times 5x is 5x. 1 times -3 is -3. Okay, divide, multiply, subtract. Let's go ahead, subtract. When we subtract, you can add the opposite or whatever you feel like it. Opposite of a positive term is a negative term. Opposite of subtracting 3 is adding 3. So we can switch it to plus. Let's see what we get. Let's see what the difference is. 5x minus 5x gives us 0 or cancel. -3 plus 3, where am I, is -10. There are no more terms to bring down, so we're good. Okay, so steps, let's go ahead and write our answer. Let's go ahead and write our answer, I'm sorry. So the answer is 2x squared minus 4x plus 1. But if we have a remainder, then we need to write the remainder as a fraction. So let me put plus and then fraction bar. Okay, the remainder is -10, and we divide it by 5x minus 3. So we're going to write the fraction as -10 plus, negative. We're going to write the remainder as -10 over 5x minus 3. Okay, guys, that's my time. A sneak peek. I'm gonna show you a shorthand for long division. So please come back. Thank you. My mouse made an appearance.